Welcome to day 68 of my 90-day SAT prep series. In today's video, I have a compilation of SAT math tips and tricks paired with SAT reading tips and tricks. Today's video is all of these tips and tricks because I want you to really know these and be able to implement them on your next practice test, which will be on day 70 of 90. So that's why I've been putting all these tips and tricks over the last couple of days, is because I think that they're really helpful and I think that you'll be able to use them on this upcoming practice test, which is why I want you to see them before it. That way you can use them on this practice test, which is your second to last practice test before your SAT if you are following the 90-day series, because there will be only one more practice test after the day 70's practice test. So I want you to have these going into this practice test, and then you can also use them obviously on the next practice test as well, but I wanted you to have them for more than one practice test. That's why I'm putting these out for day 68, and I'll also have tips and tricks for day 69's video as well. So with that, let's go ahead and get into the math tips and tricks, and then when those are finished playing, you will see your SAT reading tips and tricks for today. So as always, make sure to like, share, and subscribe, and let's get started. Today I have an SAT math tip and trick for you that deals with writing equations as you read a word problem in order to save time on the SAT math section for both the no calculator section and the math with calculator section. So with that, let's go ahead and get started. Make sure to like, share, and subscribe, and let's take a look at question number 8 from SAT practice test 7. So watch how I approach this problem. Now, as I read through the problem, I'm going to write down my equation. That way, when I get to the end of the problem and I see what I have to solve for, I don't have to go back and find all the necessary information because I already wrote down the equation. So watch how I read through this. I have Ken is working this summer as part of a crew on a farm. He earned $8 per hour for the first 10 hours. I know $8 per hour times 10 hours is going to give me $80. He worked this week. Because of his performance, his crew later raised his salary to $10 per hour. So he's now earning $10 per hour for the rest of the week. Ken saves 90% of his earnings from each week. So his total earnings in a week, he saves 90%, which is going to be 0.9 times how much he earns is how much he'll save. What is the least number of hours he must work the rest of the week in order to save at least $270 for the week? So now I see I already have my equation set up. Now if I hadn't been writing this down as I read through, then by the time I got to the end and I saw that it said, what is the least number of hours he must work the rest of the week to save at least $270 for the week, I'd have to go back through and find all this information. But since I wrote it down as I read through, I already got it here, which means that I can solve for this pretty easily. So what I'm going to do here is I'm going to take 0.9, I'm going to multiply it by 80. I believe that's going to give me $72. I don't have my calculator on me. Also, it's the no calculator section, I do believe, so I wouldn't be able to use it anyways, but I know that that's going to be $72. Okay, and then I multiply my 0.9 by 10h, and that's going to give me plus 9h. Obviously, this is going to be set equal to that 270. So at that point, I go ahead and subtract $72 from each side to isolate my 9h. Subtract $72 from each side. 270 minus 72 is going to leave me with 198. So now I have 198 is equal to 9h. Obviously, I divide each side by 9 to get my h isolated. So now I have h is equal to 198 over 9. Now, what I'm going to do here is I know that 90 is equal to 9 times 10, which means that 180 is going to give me 9 times 20. Obviously, 18 then is going to be 9 times 2, so I know that that's going to be 22. So my answer there will be 22. So my answer is going to be C. Okay, so the big tip here is understanding that as you read through a big word problem like this, if you start seeing equations and numbers like this, start writing them down as you read through. Now, if I was reading through this on my own when I was really taking the SAT, I wouldn't be pausing to tell you why I'm doing things, and it'd be really, really fast. And I can actually go ahead and show you that. I'll move my screen over to the right, and I'll show you how I would do this if I were taking the real SAT. So I won't be saying notes to you out loud like I did as I went through this the first time. I'll just be going through like I would. So let's go ahead and show you how quick this can take us, right? And I'm not going to go through and solve again. Obviously, I can do that quick. I just want to show you how I write things down. So I have Ken is working this summer as part of a crew on a farm. He earned $8 per hour for the first 10 hours he worked this week. Because of his performance, his crew later raised his salary to $10 per hour for the rest of the week. Ken saves 90% of his earnings from the week. What is the least number of hours he must work the rest of the week to save at least $270 for the week? Okay, so then I just write 270 there, and we see I've already got my equation set up. So you can see that that's a big time saver versus if you were to read through and then have to go back and find everything. So that's a big tip I have for the SAT math section, is making sure that you're writing down the equations for word problems as you read them. That way you don't have to go back and hunt down the information at the end. So hopefully this video is helpful. Today I have an SAT math trick for you that deals with setting up inequalities as you read through a math word problem. So this applies to the math no calculator section and the math with calculator section. So as always, make sure to like, subscribe, and share, and let's go ahead and get into it. So we have SAT practice test 7, and we're going to be dealing with question 9. So what I want to show you here is when I deal with question 9, as I go through it, one thing I immediately recognize just by glancing at the answer choices is that I'm going to have to set up a system of inequalities that would be used to solve this problem. Now, I don't actually have to solve the problem, I just have to find the correct system of inequalities that would be able to solve this problem. So now, the other thing that really jumps out to me here is that I've got 4 equations here. Okay, now since I have 4 equations, I know I probably am not going to need all 4 of them because there's only 4 multiple choice things and they're going to flip signs and things like that. So I know I'll probably be able to solve this after finding 2 or 3 of the correct ones. I'll know that I have the right answer just by process of elimination, since the other ones will have to be wrong. So as I go through here, my first time through, I'm just going to go through it and I'm going to teach you, and then the second time through, I'm going to show you why this saves so much time by going through how I would if I were taking the SAT. Alright, so as I go through this, just pay attention. I'll go slow the first time, and then the second time I'll show you how you can do this really quickly. So we have Marissa needs to hire at least 10 staff members for an upcoming project. Thing that jumps out to me right away is it says at least 10. So if I go down here and I look at my things with 10, I know I need to have at least 10. I see an A that it has less than 10, so that immediately to me is suggesting that A is wrong. Then I look at B, I see it has greater than 10. I look at C, it has greater than 10. I look at D, it has less than 10. That again suggests to me that D is going to be incorrect. So now I'm looking at B and C as my potential correct answers. I see the staff members will be made up of junior directors who will be paid $640 per week and senior directors who will be paid $880 per week. Now I don't know which one X and Y is yet, but I know that I've got $640 and $880. I see all of them have that, so that's fine. Her budget for paying the staff members is no more than $9,700 per week. Key part here is no more. She can't spend more than $9,700. Therefore, $9,700 must be greater than that 640X plus that 880Y. Now I know I'm between B and C here because that part with 10, right, dealing there, I know that those both are correct here, so I can check mark those two. Next thing I'm looking at is it said no more than 9,700. I see in C it shows it does have more, so I know C is wrong. I know B will be my correct answer just based on that, and I'll go ahead and show you how I know that that's correct as I go through and it tells us what X and Y mean. Right, we can go ahead and check our work. If I was in a rush, I would just click B and or select B and move on. But if we had plenty of time, wanted to check our work, we could go ahead and keep reading, and I'll show you why that's correct. She must hire at least 3 junior directors, at least 1 senior director. Which of the following system of inequalities represents conditions described? If X is the number of juniors, Y is the number of seniors. Obviously, it's got to add up to at least 10, right? X and Y do, so we know that A and D are automatically out. So then we're between B and C, and then obviously we know based on this top equation that B has to be correct. Okay, so obviously that's a really quick thing that you can use when dealing with setting up systems of inequalities to find the correct answer very fast. Now, if I were going through this on my own and I wasn't explaining it to you, I'm just going to show you how quickly I can get to this right answer. If I was in a rush, or if I just needed to move quick, or was trying to move quicker than I normally do, right? Or for me, this would just be my natural pace because I can move through these problems pretty quickly. I just want to show you how quick we can get to that correct answer of B. All right, so this is going to be a non-slowed down version that I'm going to go through right now. Okay, so I see the question 9, and this is how I'd approach it if I were taking the SAT myself. Marissa needs to hire at least 10 staff members for an upcoming project. I go down, see which ones have greater than 10. I see that my only options here are going to be B and are going to be C, so I go ahead and get rid of D and I get rid of A. Next thing I'm looking at is whatever comes next in the problem. I have the staff members will be made up of junior directors paid $640, senior directors paid $880. Her budget for paying the staff members is no more than $9,700. Therefore, I need to have a less than or equal to $9,700. I see I have that in option B. Option C does not have that. C is out. A, C, and D are out. B must be correct. So just like that, B is correct. You see that I didn't even have to read from she must hire at least 2 senior directors. I didn't have to read any of that. So I'll go ahead and put that in green. And you can see just how much I actually got out of reading. I got out of reading all of that. Okay, just by using this. Now, obviously, if you had a bunch of extra time, you could go back, check your answer, make sure that X and Y mean what we think they mean, to check your work, make sure it's correct. But if you're in a rush, you can obviously tell that's going to be correct. Even if you're not in a rush, you can kind of tell that's going to be correct. So as today, I have an SAT math tip and trick that can be applied to the math no calculator and the math with calculator sections that deals with exponents with the same base being divided and multiplied, as well as having an exponent raised to a power and then that raised to a power as well. I'll explain all 3 of those rules in today's video, and this is going to be applicable to question 11 from SAT practice test 7. I'm going to use this question to illustrate the rule for math in doing this. So I take a look at this equation. I have the expression x to the power of -2 times y to the power of 1/2, all divided by the quantity x to the power of 1/3 times y to the power of -1, where x is greater than 1 and y is greater than 1. It's equivalent to which of the following below. Okay, so in order to solve this, if you have exponents with the same base, so in this case I have x, that's the same base, and they're each raised to a power and you're dividing them, what that means is you're going to subtract. So in this case, you're going to have x to the -2, okay, and then you're just going to subtract that 1/3 from it since you're dividing them. So you're going to end up with then x to the negative 2 and 1/3. Okay, you could rewrite that then as x to the negative 7/3. Now what you can do then is just find which denominator, right? And obviously, since this is simplified, if you have a negative exponent, so in this case x to the negative 7/3, that's the same as 1 over x to the 7/3 in the denominator. That's what that negative sign means. So that's another thing that you should know. So now I know that my x has to be in my denominator. I see that that's true in a, b, c, and d. So I can't get rid of anything just based on that. But when I look at x being to the power of 7/3 in my denominator, I see that I only have that in option D, right? We have x squared, which is the same as x to the 6/3, and then we have the third root of x, which is the same as x to the 1/3, right? So x to the 6/3, and then we have x to the 1/3. Okay, and we know that that obviously, since we're multiplying, that means we're adding, and obviously that gets us x to the 7/3. Okay, which is obviously the same thing that we got when we divided. So we know our answer there is going to have to be D. Now we can go ahead and do y just for practice, although we would not need to solve for y in this situation because we know that x is correct, right? So we wouldn't even have to solve for y if we were taking this as a real SAT, unless we just wanted to check our work. But obviously just based on x, we know D is the correct answer, because if we look at our denominators in A, B, and in C, none of them have x to the 7/3 in the denominator. So D would have to be our answer. But we can go ahead and do y just for practice. So we have y to the 1/2. Obviously we're going to have to subtract this -1. So we're going to have y to the 1/2, and we got to subtract then -1 from it. So subtracting -1, we see that a minus a negative is obviously going to give us a plus positive. So we're going to have then y to the 1/2, and then we're adding 1 to that. That's going to give us y to the 3/2. Okay, y to the 3/2. We go down, take a look at D. Obviously we see D has y to the 3/2 because y to the 3/2 is equal to y times the square root of y, because obviously that's y to the 1, and then times the square root of y, which is obviously y to the 1/2. You add those, you get y to the 3/2 power. Now one thing I want to add here is just that if you were to multiply something with the same base, let's say that we had x to the 3rd power, right? And we're not multiplying here, we're actually raising to a power. And let's say we're raising that to the 2nd power. You're just going to multiply those two. So then you would end up with x to the 6. Let's say we had x to the, I'll go 4th power. Okay, and let's say we raised it to the 3rd power. Then you're going to end up with x to the 12th. So that's just one thing to note here as far as explaining the rules with exponents with the same base. Now, one thing that could trip you up is if you forget to have the same base. Okay, in order to use these rules of subtracting when dividing and adding when multiplying, and multiplying your exponents by each other when you're raising something to that power, you're going to want to have that same base, right? Or for this one right here, I'll go ahead and box it. Obviously, there's no same base because you're just raising something to a power and then to another power. But with the multiplying and dividing rule and the adding and subtracting, you're going to want to make sure you have the same base, because you have to have the same base for that to be applicable. So hopefully this video is helpful. Today I have an SAT math tip and trick for you that deals with interpreting two-way tables. So if you don't know what a two-way table is, that's this right here, right? You have a table and you have categories on this side as well as up top. So you have columns and rows of categories, and you have to be able to interpret it based on totals in the row, totals in the columns, and totals overall. So let's take a look at question 1 from SAT Practice Test 7 to illustrate my tips and tricks with two-way tables. So a lot of it is just dealing with marking up the two-way table to make sure you're not making a mistake as far as doing rows when you should be doing columns, or not doing the total. So let's go ahead and take a look at this question. So we have the table above shows the kinds of foods that are fed to cats and dogs currently boarded at a pet care facility. What fraction of the dogs are fed only dry food? Okay, key thing here that jumps out to me right away. When I'm dealing with two-way tables, I'm generally asked about fractions, right? Fractions or percentages or things like that. Now in this case, it's of the dogs only. Okay, what fraction of the dogs? So I want to know my total number of dogs. I see my total number of dogs is 25, because if I go from this row over, I see my total number of dogs is 25. So that'll be my total. Okay, so what fraction of the dogs are fed only dry food? Well, I see my fed only dry food columns right here. I go down to dogs. I see I have 2 dogs are fed only dry food out of 25 dogs. Therefore, my fraction will be 2 out of 25. Okay, so my correct answer there is going to be B. Now, when you're dealing with a two-way table, I recommend marking up the table, okay? Now, here's why. When you mark up the table, it's harder for you to make a simple mistake, or a dumb mistake, as some people would call it, right? If I didn't mark this, and I was just looking at it, I might only go to 23 and not see my total is 25. So I just recommend boxing things up with two-way tables. I think it makes it easier to prevent those mistakes, make sure that you're getting to the correct answer, not making a dumb mistake that could cost you points, especially because two-way tables, in my opinion, they can be pretty easy points, because generally it's just making fractions or dealing with percentages. So I highly recommend marking up two-way tables. Today I have an SAT math tip and trick for you that is a continuation of a tip I gave before, but is an add-on, as you need to know more in order to implement it for this type of question. Now this question is going to be dealing with question 33 from SAT Practice Test 7. So as I go through this question, I'll be illustrating a tip that I gave prior as well as adding on a new tip that you can use. So the tip I gave prior was writing out your equations as you read through the problem. Now I'm going to do that in 33, but then the difference is when I told you to write out those equations as you read through the problem before, those equations then were given as multiple choice answers A, B, C, and D, and you didn't necessarily have to solve them. Now in the case of 33 here, not only do you have to write the equations but also solve them. So I want to show you how you tackle this type of problem. So I read it, I see the score on a trivia game is obtained by subtracting the number of incorrect answers from twice the number of correct answers. So we'll let C represent our correct answers, so I'll have 2 times C, and then I'll have minus I as the incorrect answers. Now keep in mind, I here is not an imaginary number. I is my incorrect answer. So I'm actually going to make it capital I so I don't confuse that. So that's one thing I want to know also. If you're going to use I as a variable, you should use capital I so you don't confuse it as an imaginary number. So if a player answers 40 questions and obtained a score of 50, how many questions did the player answer correctly? So he answered 40 questions, so C plus I equals 40. Total score is 50, right? So we know his score is going to equal 50. How many questions did he answer correctly? So in this case, we're just solving for C. Okay, so I've got my system of equations all set up. I just want to solve for C. So what I'm going to do then is I'm going to set I equal to, right? I'll use this bottom equation. I'll subtract C from each side because I have to get I, and then I'll have all C's in this top equation, and I can set it equal to 50, solve for C. So I'll have I is equal to 40 then minus C. I plug that in for I up top, so I'll have 2C then minus that 40 minus C, and then that's going to equal 50. All right, so let me scroll down a minute. At this point, you just go through and solve, right? So you've got negative 40. I'll go ahead and add 40. Obviously, this negative sign gets distributed here and here. So I add 40 there, give me 0. Add 40 over here, it gives me 90. So now I've got 90. I've got 2C then minus negative C. That's going to be plus C. So that's going to give me 3C. 3C equals 90. Obviously, I divide each side by 3 then. 90 over 3 is going to give me 30, so I know my number of correct answers will be 30. Okay, so 30 would be my correct answer there. Now, the big tip here is making sure you're obviously writing down your equation as you read through the problem, and then at that point, you're making sure that you go ahead and solve your system of equations that you set up. Now, another tip that I want to add here as well is notice how I solved for C. I didn't solve for I. Now, why did I do that? Well, you see that obviously you could have solved for I, and I'll go ahead and get rid of this minus C so you can see it. If you look at this bottom equation here, and I'm actually going to put it in green so you can see what I'm talking about a little bit better. Okay, I'll put it in green. Let's take a look at this equation. What if I solve for I? I could solve for I and then put I into this equation of C plus I equals 40 and get that answer for C by using that method. But here's the issue with that. That's going to take me a lot more time than if I just solve for C initially. So why did I solve for C initially? Well, that's what I'm asked to answer with, right? I'm asked for C, the number of correct answers. So that's what I want to solve for. I don't want to solve for I and then go back and solve for C because that's not efficient. If I'm asked to solve for a variable, and I have two like this, solve for the variable you're asked to solve for. Don't solve for the other one and then solve for it because I get no points for knowing what I equals. I get 0 points for knowing what I equals. So I don't want to solve for I. I want to solve for C right away. Don't solve for I first. So that's another tip that you want to know for questions like this where you have two variables. Solve for the variable you're asked to answer with. Don't solve for the other one unless you absolutely have to because otherwise you're just wasting your time. So hopefully that was helpful. I have an SAT math tip for you here that deals with questions that could be found on the math with calculator or the math no calculator section. So make sure to subscribe, like, and share. And let's go ahead and get into this question as well as the tip and trick that it deals with. So this is going to be for question 5 from SAT practice test 6. So this is talking about context clues with graphs, right? So if you're asked to find a graph based on any given equation, I'm going to show you some tips you can use to find that graph really quickly and very efficiently. So I have which of the following is the graph of the equation y equals 2x minus 5 in the xy plane. Key thing that jumps out to me right away is obviously I have my y-intercept at -5. That means that any line that crosses this y-axis above 0 has to be incorrect. So I can go ahead and get rid of A. I look at B, I see that its y-intercept is -5, so B could still be a correct answer. Same with D. I look at C, I see its y-intercept is at 5, I see that's going to be incorrect. So now I'm between B and D. Next thing I'm going to look at is my slopes. I see that my slope is a positive 2x, which means since my slope is positive, it's got to go up like that. I see B goes down. Therefore, process of elimination says my answer has to be D. So when dealing with questions about graphs where you have to find the graph, make sure that you're using clues like that. Another thing is if you have a graph that is sort of a more complex one with roots, right? Let's say that you had something like x minus 2 and x plus 4. You know that you can use your roots to find that, right? So obviously your roots then would be x equals 2 and x equals -4 because you would set x plus 4 equal to 0 and you would set x minus 2 equal to 0 and solve for x. When you do that, you'd get x equals 2 and x equals negative 4. Then you could use your roots on your graph then to find what the correct answer is as well. So you want to make sure that you're using those sort of context clues within the equation in order to help you find what the graph is, right? Use those rules, use your roots, use your slopes, use your intercepts. You want to use all of those things when finding which graph is correct. You want to use your exponents, right? If you have something raised to an even power, anything raised to an even power is either going to go like this or it's going to go like this. Okay, if you have something raised to an odd power, and I'm talking about the largest power, obviously, right? So if you had something that was like x squared, we'll say minus x plus 1, then if you were to look at it really zoomed out, that x squared is going to be the most important part. So if you really zoomed out on the graph, it looks something like that. It'd have n behaviors going up, right? And that's what I'm talking about when I say going up like that or down like that, is I'm talking about the n behavior. There's going to be a little bit of movement probably in between, and I'll zoom down so I got more space to draw it so you can see that, right? If you had something raised to, and I'm talking about your biggest variable, let's say that it was raised to the 6th power, right? There could be some movement between your n behaviors. So we got our n behaviors right here. There could be a little bit of movement right around this 0 point, right? There could be a little bit of ups and downs or whatever, but your n behavior is both going to be up if it is a positive, right? Let's say it was negative x to the 6th, your n behavior then would be down, right? So you'd have your arrows going down. You could have some sort of movement around here, right? If we were to put that on there, there could be some movement there, but n behaviors ultimately going to be going down because you have x to the 6th, but you got that negative out in front of it, right? So, and then if you have an odd, let's say that we have an odd, so let's say we have x to the 5th or something like that, then you're going to have opposite end behavior. So you have one end going up, right, and you'd have one end going down, okay? So you'd have one up, one down. So you wouldn't have them both going up like you do in even. So that's just things that you can use when dealing with graphs on the SAT math section in order to determine which answer is correct. You want to look for intercepts, you want to look at slopes, and you want to look at zeros, and you want to look at end behavior. Those are the big 4 things that you want to look at when dealing with graphs on the SAT math section. So hopefully that was helpful. Today I have an SAT math tip and trick for you that deals with parabolas, their vertexes, as well as using the context clues within a graph in order to determine its equation and information about it. So let's go ahead and take a look at this graph in question 11 from SAT practice test 6. So it says the vertex of the parabola in the xy plane above is 0, c. Which of the following is true about the parabola with the equation y equals negative a x minus b squared plus c? Well, I know a, obviously, up here has to be positive. Now, how do I know that? I'm going to go ahead and show you why. If I have a graph where my largest exponent, right, and its variable here is x, is even, then I know my n behavior has to be pointed up, okay? And I know a has to be positive since that n behavior is pointed up. I misspoke there, right? I know that the n behavior has to have both of them up or both of them down. Now, if a is positive, then they both have to be up. That's how, in this case, I know a is positive, right? So I know a is positive because both my n behaviors point up. Now, if both my n behaviors pointed down, then that would tell me that a has to have a negative in front of it, right? It'd be negative a, or that a itself was negative. Now, in this case, obviously, a is positive since it's going up and there's no negative in front of it. Okay. So since I know that a is positive and I see that in my next equation, I have negative a, and then obviously I have x minus b squared, which when you do that, no matter what b is going to be, your real dominant part there is going to be that x is going to end up being squared. Okay, so you're going to have negative a x squared as one of your things. Now, since you have negative a x squared, that negative a x squared means that your graph is going to open downward, right? Because there's that negative in front of that a value, and we know a is positive. Okay, so that's going to be negative a. So we know we have to open downward. So I see I have that in b. I don't have that in a. So I can go and get rid of a. And I see I don't have that in c either. So now I'm between b and d. I look at the differences. They each have c. So the only difference then is going to be between b and negative b as my vertex, right? What's my x coordinate of my vertex? Now when I go up and I look at my equation, I see my equation for, and I'll go ahead and circle it in blue so you can see it. My equation for my parabola is given to me in vertex form, right? We see that that is vertex form. Now in vertex form, my center is going to be this right here. In this case, it's b, right? Vertex form means I'm going to have some a, in this case it's negative a, and then I'm going to have x minus, and then what in this case is b, that's where my center is. So we always are going to have x minus, and then whatever our center is. So let's say that our center was going to be represented by c. Our center would be put in that form then if we were using vertex form. So in that case, I know that then my center would be c, and it'd have to be positive, right? It's minus whatever our center is. Now let's say that we had x plus c. If we had x plus c, our center would have to be negative c then, because we're subtracting a negative c, thus giving us plus c. So if we had x plus c, we know our center would be negative c for that x coordinate of our vertex. Or I'm sorry, our x coordinate of our vertex, not our center, our x coordinate of our vertex. So in this case, I know that my x coordinate of my vertex will be b since I have x minus b squared, and that is in vertex form. So my answer then will be answer choice B for question 11. Okay, so I go ahead and circle B. I know D is wrong because it's got that negative b. So big things here that you should pay attention to, and big tips and tricks for the SAT math section, are using your graph to your advantage, right? You want to use the information contained in it to get to the correct answer. I call it the context clues. Obviously, context clues generally refers to reading and writing, but in math there are context clues as well, right? Using the context of the problem, especially in the math section. If you were to look at this graph, you can determine A is positive. Thus, when you have that negative A, you know it has to open downward. That gets rid of A, and it gets rid of C because they say open upward. Now you're just between B and D. You already know that C is the same in each of them, so you just got to pay attention to this B. Then you want to pay attention to the context clue that it's already given to you in vertex form. So then you know that x minus your center is getting squared, or I'm sorry, I keep saying your center. Your vertex, the x coordinate of your vertex, is squared. X coordinate of your vertex then must be b. So big things, paying attention to those context clues with graphs on the SAT math section is very helpful. Today I have an SAT math tip and trick that deals with the sum of perfect squares. I'm going to illustrate this tip and trick through question 15 from SAT practice test 6. So make sure to like, subscribe, and share. And with that, let's go ahead and get into this tip and trick. So we have an equation. We're asked which of the following is equivalent to it. We've got a plus b over 2. It's obviously squared. Now what this is this is going to be the sum of perfect squares. If you don't know the sum of perfect squares, it states that. I'll go ahead and give an example with x and y. Let's say we have x plus y squared. The sum of perfect squares tells us we're going to have x squared plus 2xy plus y squared. So what that means is we're going to take our last term, and it's going to be obviously squared, and we're going to take that first term, and it's obviously going to be squared, and our middle term then, since we have x times that y, will be that 2xy. So let's go ahead and apply that rule of the sum of perfect squares to this equation up top, this a plus b over 2 squared. We know obviously we're going to get a squared then, and we know that we're going to have this a, obviously it would get times the b in the other equation, and that's going to give us plus 2, because we have 2xy right here. Our xy term in this case would be a times b over 2. And then obviously we would have plus b over 2. Obviously that has to get squared, right? That b over 2, that whole thing has to get squared. Now b over 2 squared like that, that's going to give us b squared over 4 because 2 squared is 4. So that would give us b squared over 4. B squared over 4. Obviously the 2's cancel here, and we see we would have a squared plus ab plus b squared over 4. Now, in this case, when you see this equation, you should be able to immediately recognize that that's going to be the sum of perfect squares, and you should know immediately your answer then would be D. Now, I'm going to go ahead and illustrate this slowed down so you can just see how it works, right? We've got a plus b over 2 squared. Now, I'm going to show it with a plus b over 2 multiplied like this. Now, keep in mind that the form that I'm squaring right now in blue is the same as the part I'm squaring up top in blue, the same as it was written in the question above. Okay, so now I'm just going to show you how I do this. Okay, and why this works. Obviously we could use FOIL or whatever. We're going to do our a times our a, that's going to give us a squared. Then we do our a times b over 2, that's going to give us plus a b over 2. Then we're going to do our b over 2 times a. Now once again we see we have plus ab over 2, which is the same as 2 times ab over 2, in which case those 2's would cancel. Now we've got b over 2 times b over 2, that's obviously going to give us b squared over 4. Okay, now we see that we have 2 of these terms right here, right? I'll put arrows going towards them. So you see that? So obviously we have 2ab over 2. We have 2 of them. We are adding them. So we see our 2's are going to cancel there, and we're going to have ab, a squared plus ab plus b squared over 4. So our answer there is obviously going to be D. Now you want to make sure that you have this trick memorized, because if you have this trick memorized, then immediately when you see that equation up top, you immediately know you're going to have a squared, which obviously is in a, b, c, and d, so that doesn't help you much. But then you know that you're going to have b over 2, that when that is squared, you know you're going to have b squared over 4. So that helps you get rid of c, helps you get rid of a, and then for your middle term, you know you're going to have 2 times ab over 2, which will leave you with ab, so you know your answer then would be D. And you wouldn't even have to write anything because you have that memorized. So what I'm recommending you do is memorize that sum of perfect squares rule, and if you do that, it's going to save you a lot of time on the SAT math section. So hopefully that was helpful. Today I have an SAT math tip and trick that I want to share with you that deals with similar triangles. So to illustrate the similar triangles and how we can use them to save time and find the correct answer efficiently on the SAT math section, I'm going to use question 18 from SAT practice test 6. So it says, in the figure above, angle or line BD is parallel to line AE. What is the length of C to E? So we're going to look for this length right here, from C to E. So the thing I see immediately is that we have similar triangles. How do I know that I have similar triangles? Well, I see I have a shared angle right there at CEA, right? This angle E right there, I'll put it in blue. And then I also see I have a shared angle at DC to B, right? At this angle C. So I see I have those shared angles, also have this shared right angle here, so I know I got similar triangles from that, right? So now at this point, what I can do is, since I know I have similar triangles, I see that my hypotenuse CD, right? I've got this hypotenuse here. I'll put it in green so you can see it better. Okay, this hypotenuse right here. If I solve for that, I can actually solve for CE, right? And I have to solve for this hypotenuse CD before I can solve for CE, because I see my corresponding sides. In this case, I'll put it in, I'll just go ahead and highlight it. Okay, this side here from D to B, that corresponds to the side E to A and this larger triangle. And I see that the ratios there is obviously multiplied by 3, because 6 times 3 gives me 18. So I know that if I find my hypotenuse CD, then I can multiply that by 3 to get my answer for CE. So I see immediately what jumps out to me is I have a 6 here and an 8 here. I know 8 squared is going to give me 64, and I know 6 squared is going to give me 36. I know that's going to equal 100, and I know the square root of 100 is going to give me 10. So I know my hypotenuse will indeed be 10 then, right? For CD, that's not my answer though, because I'm asked for C to E. So I take that 10 then, multiply it by 3, since that is my ratio of my larger triangle to my smaller triangle, and I get 10 times 3 is 30. So my answer there would be 30 for the length of CE. So the big things to understand here is, with similar triangles, you want to find that ratio of your larger triangle to your smaller triangle, or your smaller triangle to your larger triangle. Find that ratio. In this case, multiplying your smaller triangle by 3 gives you your larger triangle for your corresponding sides. Next thing you want to do is determine what you're trying to find, right? CE in this case, that's the larger triangle's hypotenuse. Now in order to do that, you need to know your smaller triangle's hypotenuse. At that point, I applied a squared plus b squared equals c squared in order to solve for that hypotenuse. When I did that, I found my hypotenuse of 10, multiplied by 3, got 30 for the length of CE. So that's how you want to approach these similar triangles problems, is you want to identify what you want to solve, you want to find if it's in your smaller triangle or your larger one, then use the corresponding sides to find what ratio there are between the sides, and then obviously you go ahead and solve from there. So hopefully this video is helpful. Today I have an SAT math tip and trick for you that deals with applying statistics and a set of data to form a conclusion based on a survey. So in this case, I'm going to use question 7 from SAT practice test 6 to illustrate this point. So the question states, the members of a city council wanted to assess the opinions of all city residents about converting an open field into a dog park. The city council surveyed a sample of 500 city residents who own dogs. The survey showed the majority of those sampled were in favor of the dog park. Which of the following is true about the city council survey? So what I really want to show you with this question is that when we're doing a sample and we want it to be of all city residents, right? We want the opinion of all the city residents. We can't select only those who own dogs, especially when we're asking about whether we should convert an open field into a dog park. And here's why. That is a biased sample. On the SAT math section, you have to understand when samples are biased, because if a sample is biased, you cannot make a proper conclusion based on that sample, right? So in this case, we're trying to determine whether or not a majority, or whether or not basically how many people want a dog park converted, or an open field converted to a dog park, right? So we can't sample only those who own dogs, because there are people in that city who do not own dogs who may not want it in a dog park. So obviously that is a biased sample. So if we look at our answer choices, we have option A. It shows the majority of city residents are in favor of the dog park. No, because we did not survey an accurate proportion or an accurate sample of city residents. We only surveyed those with dogs, and by only surveying those with dogs, we did not include city residents who did not own dogs. So that's not showing the majority of city residents, only the city residents who own dogs. So A is incorrect. B, the survey sample should have included more residents who are dog owners. It was all dog owners, so B is wrong. C, the survey sample should have consisted entirely of residents who do not own dogs. Once again, that would be incorrect. We need that proper mix, an accurate mix in the population, right? We want the accurate mixture of those who own dogs and don't own dogs. Option D, the survey sample is biased because it's not representative of all city residents. Yes, if you're going to have a sample and you want it to be accurate, you want it to be a sample of all the city residents, and you don't want to pick a certain trait to select those residents in unless it's absolutely necessary. Now in this case it was absolutely unnecessary. We did not want to pick a certain trait, and in most cases you won't want to pick a certain trait. The only time you really ever want to pick a certain trait would be if it was a medical study and it was asking about people with diabetes or some trait like that. In that case you would have to obviously select people within the population who have diabetes if you're trying to treat it. But for most cases you just want a random sample, so always look for a random sample when you can on statistics questions. In this case obviously the sample is biased because it's those who own dogs asking about whether or not they want a dog park. So make sure that you understand if you have a biased sample you cannot make a proper conclusion based on or for the entire population based on that sample since it is biased. So hopefully this video is helpful. Today I have an SAT reading tip for you that deals with words in context questions. So words in context questions are pretty easy to tell because they end in most nearly means. So what they're going to do is they're going to direct you to some line in the passage, in this case line 14. They're going to ask you about a word and ask you what it most nearly means. Now when approaching these questions, the strategy that I recommend using and that I use to score 1590 on the SAT is when you have a most nearly means question, don't look at your answer choices until after you've gone back to the line that it directs you to, read the sentence, and come up with your own answer first. By coming up with your own answer first, it's going to help you not be swayed or get stuck between two answer choices and not know which one to pick. So in this case, let's go ahead and take a look at how I would approach this. So I'd read it, I'd say as used in line 14, simple most nearly means. I'd go to line 14 and find the word simple, and I'd come up with what I think it would mean in that context. So let's go back to line 14 and let's find simple. We see that we have line 14 on the right side of my screen. We have but change the conversation to food and suddenly efficiency doesn't look so good. Conventional industrial agriculture has become incredibly efficient on a simple land to food basis. So in this case it's talking about a simple land to food basis. Another word that we could use there would be straightforward, right? We want to talk about it being a land to food basis only, right? So on a straightforward land to food basis. We wouldn't want to use any other word than straightforward. Really there's nothing else that would mean that it's only on that land to food basis or that food to land basis. So let's go down, take a look at our question. We see we do have straightforward as an answer choice, so thus that would be our answer. Now let's say that we didn't come up with straightforward. Let's say we came up with a let's say that we thought pure was going to be our correct answer on a pure land to food basis, right? We obviously would then go through and we look at our options and find which was closest to pure. Now in this case the closest to pure would also be straightforward, so then we would get to straightforward as well, right? We look at option B, it says modest. We're not talking about a modest land to food basis, we're talking about a straightforward, a simple, or a pure land to food basis. We wouldn't say unadorned and we wouldn't say easy either. We want to be talking about something that is a pure land to food basis, nothing else but that. So straightforward or pure. So obviously you want to come up with straightforward. If you got it right away, that's perfect. If you came up with pure, then you would be looking for something that or a word that means the same as pure, which in this case straightforward does as well. So next let's go ahead and do another example of this one. So let's go down and let's find question 29. So question 29 is another words in context question. It says in line 88, sheer most nearly means what? So obviously the words most nearly means tells us it's going to be a words in context question. We're directed to line 88 and we are asked for for sheer. So let's go ahead and take a look. So let's go to line 88, find sheer. Got line 88. All right, so I'll highlight it so you can see it. So we've got, but for delivering sheer calories, especially in our stable crops of wheat, rice, maize, soybeans, and so on, conventional farms have the advantage right now. Okay, so in this context, we're talking about sheer calories. And if you want to get a little bit more context, it's always okay to read a little bit more behind, so you could read that part as well that I'm highlighting right now. But in this case, we're talking about sheer calories, but for sheer calories or pure calories or calories only. So the most nearly means I'd be looking for here would be pure calories or solely calories for delivering solely calories, but solely wouldn't work here because when we're using the word sheer, we also want to make sure that it's the same type of word as pure, right? We're describing the calories, thus it's an adjective, so we want to use an adjective there as well if possible. So in this case, we'd be looking for the word pure if that is an option. Let's take a look. Okay, we're talking about pure calories or sheer calories. We want nothing but the calories and we want them in a bulk amount. So we see we do have pure, so pure would be our correct answer there. Let's go ahead and run through. Let's say that we didn't come up with pure. Let's say we came up with solely, right? We wanted to describe it as being only calories. Well, let's go ahead and look at why A through C would be wrong then. So if we didn't come up with pure, let's say we came up with a different word such as solely calories or only calories. We can go ahead and use process of elimination, get rid of A through C. So I'll go ahead and take you through that. So option A, transparent. We wouldn't describe them as transparent calories because transparent essentially means see-through, and that's not a good way to describe the calories. Abrupt calories, we wouldn't describe calories as abrupt. Steep, we would not describe calories as steep either. We want something that's showing that they are sheer calories or only calories. That's all we're looking at. They are pure calories. There's only calories that we are considering. Okay, so then by process of elimination, even if we didn't come up with pure right away and we came up with solely or only calories, we obviously can get rid of A through C because they would not work, and C, D would be our correct answer because it's the only choice that shows that we are only talking about calories, the pure calories, meaning most nearly to sheer. All right, so I got one more example of this for you. This is going to be with question 37. So let's go find question 37. Okay, we've got as used in line 85, boost most nearly means what? So let's go ahead and go up to line 85. We'll find boost, and we'll come up with what it most nearly means before reading our answer choices. So we have, will companies be able to boost their products by manipulating online ratings on a massive scale? Okay, so this passage, you would obviously have context going into it because you would have read it. This passage is talking about online reviews and how they can be swayed by user choice and how companies could potentially use that to boost their products. Now, boost in this case would most nearly mean market or promote. Okay, they want to use those to market or promote their products. So I'd be looking for either of those. Promote would be a better choice in my opinion because it's really relating more to boost. Market is a little bit of a worse choice than promote in my opinion. So first choice would be promote if we have that. Market would be second choice. So we go down and we see that we do have promote. So our answer there would be C for number 37. Obviously, market is not an answer choice, so we don't have to worry about it. But let's say that you did come up with market and you didn't come up with promote, right? Obviously, you would see that market means very, very close to promote, and nothing else really means anything close to market, so then you would get promote anyways. But I'll go ahead and show you why A, B, and D are wrong as well right now. We wouldn't say to increase. Right, and I'm going to show you why real quick by going back to the text. Keep in mind, you can always go back to the text. It's very, very useful on the SAT reading section. We wouldn't say, will companies be able to increase their products? Because we're not talking about increasing their products. That's really vague, and it doesn't tell us exactly what we're doing. We want to be specific when we can on the SAT reading section. So anytime we can be more specific, we want to do it. So in this case, promote would be way more specific than increase because saying increase their products doesn't tell us if it's talking about customer sales or increasing the size of the product or the quantity sold or anything like that. So our answer there would not be increase. Accelerate, same thing. It's not telling us what, we wouldn't say accelerate their products. Okay, you can't accelerate a product. That would be if you were just to kind of throw a product and it moved faster. Okay, that doesn't work like that. So we would not use the word accelerate to describe boosting or marketing or promoting our sales of a product. Next, protect. Obviously, we would not protect product either. We're looking to promote it or market it. So our answer there would be C. So for most nearly means questions, obviously they are words and context questions, which means you always want to use the text. Whenever you have a most nearly means question, don't try to do it from memory. If you try to do it from memory or try to just guess synonyms, you're going to get it wrong. A lot of times they'll put synonyms as one of your answer choices just because they think that you'll pick it without going back and looking at the text, and the synonym will end up being wrong. So don't just pick the synonym. If you don't know what a synonym is, it's just a word that has a similar meaning to another word. Don't just pick the synonym. Go back and look at what the word actually means in the context of the sentence. That's the only way to get these questions right consistently. So you want to make sure that you're doing that. Also make sure you come with your own answer choice first so you don't get stuck between two or are swayed by other answer choices. So hopefully this was helpful. If it was, today I have an SAT reading tip and trick for you that deals with shifting focus over the course of a passage. So to illustrate this tip and trick, I'm going to use questions 1 and question 32 from SAT Practice Test 5. So question 1 comes from a passage describing a young boy's dining experience as he reads a book and then awaits the entrance of his father, and then eventually his father comes into the restaurant and sits with him and dines. So over the course of the passage, the primary focus shifts from what? So the things I want to discuss when talking about the primary focus shifting within a passage is you want to make sure that you're maintaining the big picture. A lot of times you'll get caught up in something that's too narrow. For example, answer choice C in this case is too narrow. It talks about the physical setting of the scene, shifting to the different characters' personality traits, but the physical setting of the scene is never the primary focus. Okay, so in the beginning, the primary focus is not the physical setting of the scene. Now, do we describe the physical setting of the scene? Yes, but we would be focusing too narrow on that physical setting of the scene if we were going to pick C, and we would end up getting that one wrong. So we want to avoid focusing in too narrow on one part of the passage. When we're asked to talk about the primary focus shifting over the course of the whole passage, we want to make sure that we're looking at the big picture of the passage. And the big picture of the passage means we're not focusing in on one little detail. So we can go ahead and get rid of C. Now, another reason that a lot of people get questions like these wrong is they use incorrect relationships. So they read the passage and maybe they misunderstood something, or they skimmed the passage and ran out of time, and they end up picking an answer choice that has an incorrect relationship. Now, in this case, answer choice B has an incorrect relationship. Now, what do I mean by that? Well, on the science sections, it's more common that you'll have an incorrect relationship, and obviously in that case, you're not necessarily going to be shifting a focus necessarily as much, but you may be. So on the science section, the incorrect relationship may be between two different variables, but in this case, this was the literature passage, and in this case, the incorrect relationship is stating that Limey, who is the main character in this, he's the young boy, has an exchange between strangers, okay? In this case, his exchange is between his father and him, okay? So because he does know his father, this would be an incorrect relationship because it describes them as strangers, so B would be incorrect. Now, another common incorrect answer choice on shifting focus throughout the passage deals with something that is just off topic, unrelated, or incorrect. And that's what answer choice A is here. Answer choice A says that Limey's inner thoughts his inner thoughts to observations made by other characters. Here's what's wrong with this. There are no observations made by other characters because the only characters that are really talking or making observations in this are Limey and partially his father. Okay, so any observations made by other characters, that's impossible because no other characters are making observations. So A would be incorrect because it's an incorrect it's just an incorrect statement. It's not related, it's off topic, and it's just not true. So it's not a reverse relationship, it's just not true. So A would be incorrect there. B is obviously going to be our correct answer then. It shifts from Limey's experience reading a book to descriptions of people in the restaurant. Right, that's the big picture focus on this passage. So when you're asked to talk about the primary focus shifting within a passage, make sure you look big picture. Don't focus in too narrow on one thing. Also make sure you have correct relationships and make sure that you're avoiding saying something that's just factually incorrect. So that's one example of a question like that. Now, another example of a question where you're asked to talk about shifting focus throughout the passage that has kind of a different setup as far as the answer choices is question 32. So I'm going to go ahead and show you that one real quick as well when talking about shifting focus within a passage. So question 32 is different in that its wrong answer choices, they don't necessarily display the same characteristics that were in that question 1. So if we look at question 32, it talks about over the course of the passage, the main focus shifts from a discussion of an experiment and its results to what? So in this case, they're giving us the beginning, right? They're giving us what we're starting our passage with, our initial focus. And we're asked to finish with what our final focus is. So in this case, what I want to talk about is why you can't always use the general idea of finding one answer choice that's too narrow, one answer choice that has a reverse relationship, and one answer choice that's incorrect, because sometimes you'll have three that are just factually incorrect. So if you're stuck thinking in this box of I have to find a reverse relationship and I have to find one that's too narrow because both of those have to be there, you could get it wrong because they don't both have to be there. Now they can both be there as wrong answer choices, but they don't have to be. Now if we look at this, answer choice A, we have an explanation of the practical applications of the results. Now, we never provide an explanation of the practical applications of the results in this passage, right? And I'm not going to read the passage to you because that's going to take too long, but we never do that. That never occurs. So that would just be factually incorrect. Okay, that never is discussed in the passage. Therefore, that's just going to be automatically wrong. A is incorrect. Okay, there's no trick there as far as it being too narrow or it being a reverse relationship. It's just not in the passage. Now, if you look at B, a consideration of the questions prompted by the results, that's going to be our correct answer. I can quick show you those questions prompted by the results that we finish with. We see we have the questions. One question is whether the positive herding, I'll go ahead and highlight it, is whether the positive herding bias is specific to this site or true in general. Watts says, he points out the experiment. He talks about economics being a much stronger effect. He asks what explains the difference. So we're really imploring these questions after that. So B is going to be our correct answer there. Now I want to discuss C and D as well, show you why we can't always count on one answer being too narrow, one being reverse relationship, and one being off topic, because sometimes all three are just factually incorrect. So we have C, an analysis of the defects undermining the results. We never discuss defects that undermine the results. So once again, factually incorrect. Okay, so I hope that you're noticing that you can't just rely on picking out one answer choice that's too narrow, one answer choice that is maybe factually incorrect, and one that's reverse relationship, because sometimes you'll have three of one kind of incorrect answer. So you can have that as well. D, a conversation with a scientist who disputes the results. There is no conversation with a scientist who disputes the results. Once again, it's not even in the passage, it's just factually incorrect, right? It's just not in the passage. Okay, so answer choices A, C, and D were just not even in the passage. So answer choice there was going to be B. B is the correct answer there. So I hope that gives you a better understanding of looking at wrong answer choices, not necessarily getting too caught up in the idea of finding different types of wrong answer choices because they can have the same type as being wrong the wrong answer choice in 3 of the options. So hopefully that was helpful. Today I have an SAT reading tip for you that deals with answering question sets based on 2 passages. So whenever I'm answering question sets, such as in SAT Practice Test 5, questions 11 through 21, and I have 2 different passages, I use a certain strategy to make sure that I'm being really efficient and making sure that I avoid confusing different information from both passages. So I'm going to outline how I approach 2 passage question sets like this. So I'm going to go over to my right here, and I'm going to show you some notes as far as how you can strategize for these 2 passage question sets. So what I do is I read through passage 1 first. So I'll go ahead and read the prompt, and I'll read this little prompt up here that I'm going to circle in blue as well. I'll read that as my first step, just so I understand what passage 2 will be about in a general sense, so I can be prepared to answer that as well, or once I get to it. But the first thing I'm going to do is I'm going to read through passage 1. Okay, so first step is going to be read through passage 1. So I'll write read passage 1. That's the first thing I'm going to do. Next thing is I'm going to answer the questions that are only about passage 1. So I'm going to write answer the questions on passage 1. So on P1 for passage 1. Now after I answer the questions on passage 1, I'll reach a point and it'll ask me something about passage 2. Once I reach that first question asking me about passage 2, at that point I don't answer it quite yet. I go and I read passage 2. So I'll go back then and I'll read passage 2. Now after I read passage 2, I'll answer the questions that are only about passage 2. So I answer the questions that are only on passage 2. So only on passage 2. After I answer those questions that are only on passage 2, at that point I will go back through and I'll answer any questions that ask me to compare or contrast them, or any questions that asked about both of them together. So if I saw passage 1 and passage 2 contained in one question, I will go and answer those. So answer questions on passage 1 and passage 2 together. Alright, so why do I do this? I'll quick explain this because I think it's really important that you understand why this is important to do. So if you read passage 1 first, what that's going to help you do is not conflate the information contained in passage 1 with passage 2. So by reading passage 1 first and then answering questions on passage 1, you're not going to confuse any information between the two. Because oftentimes passage 1 and passage 2 and paired passages like this, they're going to be about a similar topic, right? You'll have one that makes one argument and one that contrasts that argument, or one person that advocates one thing, the other goes against it, or the other goes for it, but with a different slant, and things like that. So they're often on a similar topic. So by reading passage 1 and answering the questions on passage 1 first before reading passage 2, it's going to prevent you from confusing the two and getting an answer wrong. Next, I'm going to read passage 2 and answer the questions that are only on passage 2. So once again, making sure I'm not confusing the information between the two by using this strategy. And then finally, I'm answering the questions that deal with them together. So by doing that, it's going to help me not confuse the information, not bring information from passage 2 into a question that only deals with passage 1. So that's my recommendations for questions that involve 2 different passages at once. Now, like I said, obviously I didn't put this as a step, but the first thing I'm going to do is I'm going to read this entire introduction sort of deal, right, that I'm putting this arrow by that's circled in blue here. I'll read that first, then I'll read passage 1. So that's just one thing to add as well. So hopefully that was helpful. If it was, make sure to like, subscribe, and share, and as always, have a great day.